video, we are going to discuss about colorimeter, its principle, instrumentation and uses. Colorimeter is a form of photometer. It is a form of photometer. It mainly deals with the measurement of light transmitting power of a colored solution. The measurement of light transmitting power of a colored solution, so that to determine the concentration of the light absorbing substance present within it. Suppose if we have a solution with an unknown concentration, we want to find out the concentration of that solution, we can use the colorimeter. By measuring the light transmitting power of that colored solution, we can determine the concentration of the light absorbing substances present within it. It was invented by Louis J. Dubosca in 1870. Louis J. Dubosca in 1870. The concentration of the colored solute in a solution is estimated by comparing its color intensity with that of a standard solution containing a known concentration of solute. That is, the concentration of the unknown sample or unknown solution can determine by using a standard solution. That standard solution contains a known concentration of the solute. So, by comparing the color intensity of the unknown solution and standard solution, we can identify or we can find out the concentration of the solute present in the unknown sample. Now coming to the principle of colorimeter. Principle of colorimeter. When a beam of incident light I0, intensity I0 passes through a solution. A beam of light with intensity I0 passes through a solution. This contains the solution. So, when a beam of light with intensity I0 passes through the solution, a part of incident light is reflected, that is denoted by IR, and a part of incident light is absorbed, that is IA, and a part is transmitted, that is IT. So, when a beam of incident light of intensity I0 passes through a solution, the following events are occur, that is, a part of the incident light is reflected, that is denoted by IR, and a part of incident light is absorbed, that is IA, and the remaining incident light is transmitted, it is denoted by IT. And the light that is not absorbed is transmitted through the solution and gives the color to the solution. That is, the light that is not absorbed is transmitted to the solution and gives the solution its color. And the color of the incident light, should be complementary to that of the color of the solution. The color of the incident light should be complementary to that of the color of the solution. And the ratio of the intensity of transmitted light IT to the intensity of the incident light I0 is called transmittance. That is, T equals IT by I0. That is, the ratio of the intensity of the transmitted light to the intensity of the incident light is known as transmittance T. And the absorbance of the solution A, absorbance of the solution A is defined as, that is equal to the logarithm base 10 log of 1 by T. Absorbance equals base 10 log of 1 by T. That is, A equals log 1 by T. measurements are dependent on two important laws, that are Beer's law and Lambert law. Beer's law states that when a monochromatic light passes through a colored solution, the amount of light absorbed is directly proportional to the concentration of the solute in the solution. That is A directly proportional to C. A directly proportional to C. That is, the absorbance is directly proportional to the concentration. Now coming to the Lambert's law. Lambert's law states that when a monochromatic light passes through a colored solution, the amount of light absorbed is directly proportional to the length L or thickness of the solution. That is, the absorbance is directly proportional to L or L length or thickness of the solution. Then combining these two laws, we get Beer-Lambert's law. Beer-Lambert law, that is A equals A directly proportional to C L, where C is the concentration, L is the path length. This we can write as A equals epsilon C L, where L is the path length, C is the concentration, and epsilon is the absorption coefficient. Epsilon is the absorption coefficient. And if the path length is same, that is, if we are using the same cuvette, we can use this equation to find out the concentration. That is, concentration of test equals absorbance of test divided by absorbance of standard into concentration of standard. Now coming to the instrumentation of colorimeter. This is the instrumentation in a colorimeter. Here we can see a light source. First one is a light source. Usually tungsten lamp is used as light source. Tungsten lamp is used as the light source, and it produces energy at sufficient intensity throughout the whole visible spectrum, that is 380 to 780 nanometer. 780 nanometer. It produces energy at sufficient intensity throughout the whole visible spectrum at 380 to 780 nanometer. This is the light source. Next is slit. This is the slit. It allows a beam of light to pass and minimize unwanted light. And it allows a beam of light to pass and minimize unwanted light. Next is condenser or condensing lens. It gives parallel beam of light. Parallel beam of light. Condenser gives parallel beam of light. Next is monochromator. It mainly used to produce a monochromatic radiation from polychromatic radiation produced from the light source. That is, it produces monochromatic radiation from polychromatic radiation, that is produced from the light source. And it allows only the required wavelength to pass through it. This monochromator allows the required wavelength to pass through it. Usually prism, gelatin fibers, grating monochromators are also used as the monochromator. Prism, gelatin fibers, grating monochromators or interference filters also used as the monochromators. Next one is sample holder. Usually cuvettes are used as the sample holders. They are glass or clear plastic cuvettes. Glass or clear plastic cuvettes, and they must be transparent. The sample holders must be transparent. Usually we are using cuvettes. Cuvettes are glass or clear plastic cuvettes. Next one is detector or photocell. Detector or photocell. The detector mainly receives the light beam once it is passed through the sample. It receives the light beam once it is passed through the sample and convert it into electrical signal. So the detectors receives the resultant light beams when it is passed through the solution and through the sample and convert it into electrical signal. Usually selenium photocells or silicon photocell, phototube or photomultiplier tube. Usually selenium photocells, silicon photocells, phototube or photomultiplier tubes are used as the detector. Now coming to the uses and application of colorimeter. In clinical laboratories, the colorimeter is used for the estimation of various biochemical compounds in variety of biological samples like blood, plasma, serum, CSF, urine and other body fluids. So clinically it is used for the biochemical estimation of biological samples such as blood, plasma, serum, cerebrospinal fluid, urine and other body fluids. It also widely used for monitoring the growth of bacterial or yeast cells. Yeast cells in liquid cultures. So these are the application of the colorimeter. This is all about colorimeter. Thank you.